Hi, and welcome to this video on control flow, in which we're going to look at instruction flow in relation to branching. Okay, control flow. Why is it called control flow? What is the deal with that? So the idea is to picture instructions as flowing through the computer. Like we talked about in the computer use section where we were looking at streams, the idea of data flowing in streams between programs. We can think about instructions as flowing like a stream through the computer. And here's a little visualization where I tried to capture that. So we can imagine that we've got a number of instructions here. So instruction 18, 19, 20, 21, and 22. And the computer has run instruction 18, instruction 19. It's up to instruction 20. It's running that at the moment. And instruction 21 will be the next one. They will flow through the computer, each instruction getting the computer to perform something. The way sequence works is through what we call the program counter. So the program counter is a value. It's like a variable inside the CPU that keeps track of which instruction we're up to. So we're up to instruction 20 at the moment. When instruction 20 finishes, it will add 1 to the program counter, so that will become 21, and we'll be on to the next instruction. So all of those will move sort of that way, one in our visualization, flowing through the computer. Now let's have a look at ways of controlling that flow. So control flow is all about controlling that flow of instruction. Really, we're just saying, how do we inject points where we make a decision and choose to have a different instruction next rather than the one that follows this instruction? That's all control flow statements are. But we can limit the way we think about these to give us some structure, and that was the idea of structured programming, so we organize this around blocks. The first kind of block that we can look at is the branching block, selection. This is where we inject a condition and we use that condition to jump to one path or another path and creating branches in our program's code. So those branches let us go one way or the other. We can picture that like this in something like a flowchart type symbol. The program gets to a certain point, it makes a decision based on a condition, and it goes one way based on the value that is made. Usually there's two ways, and we'll have a look at those different details in a second. Using our flow visualization, we can picture it like this. Instruction 20 might be a decision. So you see I've got that little decision logo in the background behind the CPU there. So we're making a decision in the CPU, and its decision is what instruction should go next. Instruction 20 is looking at a condition, so the condition that we've programmed into the code, and saying, is this true or false? And based upon that condition, it's either going to let the instruction flow to the next instruction, so it will come down this way, and it will go through this. So this is one branch, and it will at some point join back together. Or it will go the other way, and this is the other branch. And so in our code, what we'll see are these two branches. With structured programming, the idea is that each of these branches, whenever you have these decisions, they go out and they always join back together after the branches are finished. So the two branches and we join back together. This is all achieved using the program counter. So what instruction 20 will do is based on that condition, if it's going to choose this bottom path, then it will just do the default add 1 to the instruction, and so it will go to 21. If not, then what it will do is it will set this value here. Instead of it becoming 21, it will set it to 23, and so the CPU will then jump to the instruction and follow this branch, and it will keep running in sequence at that point. We're really just changing the sequence, what's going to be the next instruction in that sequence. Here's an example of that occurring in C#. So what we've got here is the if statement. The if statement is the first control flow statement we're looking at. If is followed by an expression in brackets, and that expression has to be a Boolean expression. So here our expression is, does language equal C#? If the language equals C#, one branch is to run through this code here between the open brace and the close brace. And the other branch, there's no actual code in it, is just to jump over that and not to run it at all. So there's always at least two branches. So the two branches here are, if this is true, go to the next instruction and execute this right line here. If this is false, so that will be the true branch. If this is false, then we skip over it. And when you read through it, it should make logical sense. You know, if the language equals C#, then right line, hello, right line, good choice. C# is a fine language. But if language does not equal C#, what happens? Well, we don't want to print out good choice. C# is a fine language, so we jump over those and we keep going. Both of them will print out the great chat message. You can have an if with an else as well. So in this case, we do the same thing. So we've got the if condition here, and we have our two paths. The first path comes into here, that will be the true path. It will execute those instructions. And when it gets to the end of those instructions, what it will do is it will jump over. We'll go around here. There we go. You get the idea. It will jump around there and it will skip the else part. If it's false, what happens is it jumps down here and it goes into the else branch, runs these instructions, and then keeps going. So they rejoin back together here, and both paths then print out the great chat message. So what happens? We get to the if statement. We evaluate the expression. If this is true, does language equal C#? Yes, it does. We come this way, and then we jump over the else branch. If it's false, we go this way, and we execute this branch here, and we join back together and print out great chat. So if the user typed in C#, they'll get good choice, C# is a fine language, great chat. If their user types some other language, say C++, then they will get, well, good luck with that, great chat as the output. Let's have a look at working through this in the else if statement. So this is the ability to combine together multiple if statements in the language. This is one of the sliders from the text. So we read the language, and let's say the user types C# here. That value will get loaded into the value of the variable on the stack. So we've now got C# in the language. So when we get to the if statement, we compare, does the language equal C#? How do we do that? Well, let's look at language. Language is C#. Does C# equal C#? Yes, so that is true. And that means we're going to now jump into this code here, and it's going to execute write line, and it's going to get to the end of that block with the closing brace. It will then jump all the way over that. Once we get here, it will then jump over that to come down and execute the great chat. So that will be the path that gets taken by the code. So we're capturing that here again. So once it's jumped over the instructions, when we get to the else, that indicates the next part of the if statement. And so yeah, we don't execute the else part if the if statement part was true. Let's try it again. So if we run this again, now the user has typed C++. We are storing that, so that's the read line here. We're storing that in language here. And when we go to the next instruction, we check if language equals C#. What's language? Language is C++. Does C++ equal C#? No, it doesn't. So that is false. False means we've got to now jump down to line 8 and execute the instruction in the else branch. The statement inside the else branch is another if statement. And so this if statement runs just like the first if statement. It's exactly the same idea. We're going to do the comparison, and then we're going to jump to one of the statements. So we can check, what's the first comparison? All right, we've got a OR here, and we've got language equals C. So we look in language, C++. C++ is not the same as C, so the answer to that is false. Because it's an OR, we keep going and we can check the second part, and we can see if this is true. Does C++ equal C++? Yes, it does. So that's true. Because this is true, we're now going to jump into this block of code and execute this branch here. Because the language was C++, we've jumped into the branch. We now run through all of the instructions here, and when we get to the end of that, so that close brace there, we're going to jump over the else and get down to the great chat here. Let's go back and try this one more time. So we'll go through it again using the Fortran language. All right, so the user has entered Fortran down here, and so we've stored that in the variable on the stack. When we get to the comparison, does language equal C# is false. So this means that we jump over the writing out to the else and into the next if statement. We check if the language equals C or the language equals C++. Fortran does not equal C, so the result of that is going to be false. Language does not equal C++, so the result of that is false. So Fortran does not equal C++, Fortran does not equal C. As a result, we're going to jump over this here and go into the else branch that matches this if statement. Yep, so this if will have the next else. And so now in this one, we get the text, well, good luck with that printing out. We can see that down here where we've got that printing out. So that's how the main control flow mechanism related to selection or branching works. We get to a point in the code where we make a decision. So we have the if here where we make the decision, and that means we either run this block of code or we run the matching else block, which in this case is all the code from there all the way down to there. The same occurs with that second if statement. So where we have this if statement here, it, based on the decision here, it either jumps into this code here or it jumps into its else branch, which is this code here. And so you can use these if statements to create points in the code where you make a decision and let's either run the block of code or jump over a block of code, depending on the value of that condition. So crafting these conditions is really important. The other kind of branching statement is the case statement or the switch statement. This lets you provide an expression and a number of different options. It's a shorthand way to get the compiler to add in all of the comparisons for you. It still has to do the comparison with each branch, but it's just less code in terms of what you have to write for those comparisons, instead of a whole sequence of else ifs. If you're looking at comparing with one value, you can do that with a switch statement. Let's have a look. Here's an example switch statement here. So in C#, we can do switch statements with strings. In other languages, you might not be able to do that. So here we've got the switch statement. So what's happened to start with? The user has been asked what language they use, and we've read in the details of that language and we're storing it in the language variable. And based on the value of the language, the compiler is going to in effect create an if statement that says, if the language is C#, then execute this block. If the language is C, run this block. Else if the language is C++, run this block. Otherwise, or else, run that block. So this will then match the value, or the switch will match the value in the brackets here against each of these cases. Where it determines the end of the block, the end of the bit of code it runs, is based on the position of a break. So the way this would work, when we execute this, we would come down. So based on the language, if the language is, say, C++, what will happen is it will compare it against C#. It's not C#, so it'll compare it against C. It's not C, so it will compare it to C#. It is C++, so it will then start executing this code here. And when it gets to the break, that's an indication to jump to the end of the switch statement. And no matter what, we'll always continue from that point and go onwards to the next thing. So those are the main branching statements within control flow. They let us code a position where we have a condition, and based on that condition, we choose one or a different path. So we craft the condition to determine which set of instructions get run next. Good luck with your exploring the topic of branching.